Greetings. All right, time to go over some code. We haven't done that in a while. So what I like to do is just take a look at a lot of the code that I have presented to you in the lectures repo, and we'll begin with figure A1. And so I'm here. It's not Cygwin, but it's close enough. It's a Windows subsystem for Linux. All the commands I'm going to do would be done exactly the same way in Cygwin, so don't let that bother you. Again, this is the lectures repo, and make sure I have the latest and greatest. I'll just do a pull, and everything's up to date. So I'm going to do all my editing in Visual Studio Code, and you should be able to just type code and then period, saying that you want to open up the current folder in code. And again, I'm in the lectures repo right now that I've cloned. And the Windows subsystem for Linux is opening. I have that plugin on Visual Studio Code, which basically lets me read from the Linux file system as if I were reading from the Windows file system. And in the source folder, I've got a couple of things here, and under review, I want to take a look at figure 1A. So first things first, let's just perhaps make this a little bit bigger so we can see better. Maybe one more time. There we go, and that's nice and big. Excuse me. So let's kind of just go through this. These are messages from Git, so don't look at that. It's not part of the source code. And what we have here on line 1 is the way that we introduce parts of the C++ library that aren't included in the general language itself. And so IOStream is a library that includes things that we need to do stream input and stream output, or stream extraction and stream insertion, if you will. Printing to the console, reading from the console, however you want to say all that. And so that's what line 1 does. Every executable program has to have an entry point, and that entry point is defined by a function called main. Main actually has a couple of different signatures. This is a straightforward one, as simple as it can get. We claim that we're returning an integer, and it has no arguments. And then on line 4, we have this single line comment that's created by the 2 slashes in a row, and basically what you're doing is you got a comment that goes from there to the end of the line. Shouldn't state the obvious, right? But if there's any tricky parts of your code, you do want to make a comment to indicate what your strategy is or why you're doing what you're doing. And then, excuse me, on line 5, we declare a constant. It's of type double, and we're giving it the name pi, and it is to represent the value of pi itself. And the naming convention here to use all capitals on constants is just a convention. It's by no means a requirement. Helps you, when you're looking at your code, recognize that, hey, this is something that is unchanging, and I better not try to change it. And then on line 6, we declare another variable called radius, and this is also of type double. And then on line 8, we are outputting some text. So you may be used to using that phrase, like I'm going to output this line of text or whatever. Actually, what's going on here is that this pair of symbols represents what we call the stream insertion operator. And what we're doing is we're inserting a stream of characters into the standard output stream. And so the arguments here are on, it's a what's the word I'm looking for? Binary operator, and it has 2 arguments. The operator on the left is an instance of cout, and then the operator on the right is, operand rather, on the right is a stream of characters. And so what we're doing actually is we're inserting this collection or array of characters into the standard output stream, and that's one way to help you remember the direction of these arrows. All right, we're inserting this stream of characters into cout, and again, cout is representative of the standard output stream. Likewise, on line 9, we're reading from the standard input stream. So in other words, we're extracting information from the output stream. All right, so that's why these arrows go this way. They're coming from this object which represents an input stream, and we're extracting the elements of the stream into this variable called radius. So again, that's one way to help you think of the direction of the arrows. We insert things into a stream, an output stream. We extract things from an input stream. So this is how we get the text enter the radius of the sphere on the screen, and then when we type in a number and hit return, we're extracting the number portions of what's in the stream into a variable called radius. And then we have another declaration of a variable called volume, and we're initializing it right away to be the value of this expression. An expression is just something that evaluates to something. All right. So in this case, we've got an arithmetic expression, and it's going to evaluate to a double value, right? A value of type double. And all we're doing is 4 times pi times radius divided by 3. And this brings up a good point. You know, a lot of people are often tempted to use like math.pow to do radius raised to the second power. And I urge you not to do something like that on a small calculation like this. Multiplication is going to be a very fast operation, and calling a function just to raise something to the second power is a waste of resources. Likewise, even if you raise something to the third power, just multiply it out. It's a lot more efficient than calling math.pow. And then finally, we see here that we can output a bunch of text, and embedded in that text we could have the value stored in these various variables. /n is a special character for printing a new line, and then we return 0. So that's a straightforward, very, very basic program. Let's take a look at how we might compile this, a number of different ways we can compile this. I'll do that in another video. I want to keep these videos short.